Okay. Hello everyone, welcome to my channel. And in this video, we are discussing about problem of the day of GFG, and it is basically a question known as BST to Max Heap, right? So, as we all know about the BST, and we are well known with the Max Heap properties. So, let me have a problem statement first. So basically, we are given a BST and we have to convert the BST into a special max heap with the condition that all the values in the left subtree of the node should be less than the values in the right subtree of the node. This condition is applied to all the nodes in the converted max heap. So let me show you what I am trying to explain. So as we know that BST we are given and we have to convert into a special maxi with a condition. And what we are given a condition. Let me show what the condition we are given that the values in the left subtree. So let me denote as a left subtree by L of the node should be less than the values in the right subtree. Let me denote it by R, the right subtree values, right, for a particular node. Fine. So this is the value, like into the special right. Okay. Okay. So this is the value, right? So in the max heap, we all know that if whenever we are making a max heap, we have a node. So suppose we have a node. So basically, it is greater than our left subtree values, and simultaneously, we have our node value greater than from the right subtree values. Is it fine? This is for max heap, max heap property, right? Now in the BSC, we also have one property that is that all the left subtree values should be smaller than all the right subtree values. You must be knowing that already, right? We have two conditions, right? And I discuss this property for a particular node, and this property should be basically applied to all the nodes in a BSC as we further traverse. Is it fine? So let me again like read the question for you so that you can understand the question pretty much well. So we are given a BST. Like what is BST? The left nodes are smaller than the root node and the right nodes are greater than the root node, right? And we have to convert BST into a special max heap with the condition that all the values in the left subtree of the node should be less than the values, all the values in the right subtree of the node. This condition is applied to all the nodes, right? So basically, in a like VST, we have this property that all the nodes in the left should be smaller than all the nodes in the right, right? We have this property, and we are given a condition for the maxi that our node value should be greater than the left subtree, and our node's value should be like greater than the right subtree. We are given that. So if we combine like both the conditions, what we are going to have, like we can see that L is smaller than N and L is smaller than R. So L is the smallest, and now N is greater than R, and N is greater than. So we are having R, and then we have N, right? So this is the property that holds for that. So that is the basically trick in the whole question. We have been deriving this, so we got our question solved, right? So basically, the question boils down to nothing, but we have to arrange the values of a BST in such a order that this condition holds true. Now, how we will arrange, like what is the order, like which node will come that way, right? So we have to derive a way. So basically, if I think of this order, this is left, right, and node. So what is this order called? So as we all know that this is a post order in which we first go to the left and then to the right, and then we perform the operations on our node, right? So this is a post order type thing. So, this is a post order. Now, question boils down to we have to convert a tree in the order of the post order. But which values should be taken? You should have some values like that should be taken into consider whenever you are making a post order, right? So, what we are doing for that is that we want a sorted we want a list of sorted values of the tree. So how we get a sorted list? So as we all know that if we calculate the in order of the BST, so we get a sorted order of of the values of a particular BST, right? So the question, so if we calculate the in order, we get a sorted array, right? Sorted array of the root value, right? So the question, so the algorithm, if I write, so it is pretty much simple. So first of all, we will take a vector and I will store the values, the in order traversal of the whole BST into a vector so that I can get a sorted vector of the values. And now what I have to do is that I have to maintain this condition hold, this will hold true. So I will just make the values according to the post order. Like I will make the tree from the given values in the in order in the form of the post order, right? You will be much clear of this in the when we deep down into the code. And this is the whole idea of the particular question, and this question is the tricky in that thing only. If you want to, if you will able to recognize this, you will be able to ace the problem. So I hope that you must be understanding the approach. And one question that is also made from this question is BST to max heap. And suppose you are given a question like you have to make BST to min heap. So how you will approach that problem also? This is a like let me write BST to min heap. So only one catch is there in that also. In min heap, what is the condition? We have the node values basically is smaller than the left, and then simultaneously we have node value smaller than right. And for BST, we have L is smaller than R. This is a condition you all must be knowing. So if I combine both the conditions, what I am getting is that basically node is smaller than left and right, and now L is smaller than R. So this is L, this is R. So this is the condition for BST to mini. And now let me describe you what it is showing. So one second. Yeah. So you understand this. Only the difference is that you have to derive the condition. And what this order is, we have node and then left and right. So this order is pre-order. Only the difference is there that in if you want to convert into the mini, you will have to arrange the nodes in the order of the pre-order. And the same first step you want to do is that you can calculate the in order because you wanted a sorted keys, right? And then sorted array, correct? And then you will calculate the particular order. So the algorithms in both the cases that first of all you have to find the in order. You can store the in order in some vector, and then you have to like uh, rearrange the tree in the order of the pre-order. If it is the question is that you have to convert BST to maxi, and if it is given that you have to convert BST to mini, then you have to just convert the in order into and rearrange the tree into the order of the pre-order by the giving by the given values of the in order array, right? So this is the algorithm, and this question basically explains two questions like BST to maxi that I have explained, and the BST to mini that also have explained. So this question has been asked in the shop. So it is quite a good question that may be asked in an interview. So it is a good question that you may find in an interview like BST to Max Heap or BST to Mini. So let me deep down into the code and explain you the code. So what I have done is that we are given a function that convert to max heap util, and we are given a root node. And what I have done is that first of all, I check if root is null, then you have to return, no need to further process. Then I have made a vector in order that I have shown, like you have to store the in order. So in order, so I have made a vector that stores the in order. And now I have made a function f, and I have like pass on the root and the in order vector. So this is a function here. So this is a void function, and this is used to calculate like the store the in order. So I have taken the root and in order vector by address so that it stores the value. And if I have checked if root is null, then you have to return, right? Because you must be knowing the in order, how to store in order, right? So this is the straightforward type of this. And now we move on to the left, passing on to roots left and in order. And now when we move on to left, and after that we will push back our roots data to in order vector. Like processing is done in middle between left and right. You must be knowing that. So in order start pushback roots data, right? I will now this will store the data of in order, and now I will move on to roots right and passing on to the in order, right? Correct. So after this step, after this step, my in order vector should be ready in the sorted order of the like values of the root, right? And now I will calculate the int n is equals to in order dot size, right? And now the basically the build heap function that I have told you that you have first of all you calculate in order, then you have to like iterate in the post order way and put the values into the basically put the values of the in order array in the form of post order in case you have to maintain a maxi, right? So what I have done, I have passed on n root and in order array. So this is the main function. So this is a simple post order. You must be knowing that. So basically, if I have checked if root is equals null, so I have to return like for this tree. So if I am because this tree is already been made, so my tree basically structure does not change, right? I only have to like make changes to the values. So if my root, I am traversing on the same tree BST that I am given because I only have to make changes to the values. I don't have to make a new tree, right? So if root equals null, I will just return. And if the second condition is if I is equals n, I will return. What is I? So I have declared I as 0. This is basically because I have to track for the index of the in order array that I am basically traversing to change the value in the BST. So I have made it global because I don't want to take any tension of like how to pass this in the function. Like this is recursive function, so this is a pretty easy task. So if I equals n, I will just return. Or like you can give this condition or you can omit this condition also because like you are not maintaining a new tree. You are only making changes to the pre-existed tree. So obviously you have made the vector from the BST itself. So this if you have written this condition itself, this will also work because if root equals null, your array will automatically finish. It's of course true. So I can omit this condition as well, or you can maintain it no harm. So what I have done is that to in the post order, what we have done is that we have called a function passing the n roots left and in order, and the second then I have like want to build heap n roots right in order. And first, then like in the post order, what we do, like we go to the left, we go to the right, and then after that we just perform some operations, right? So what the operation I have told you that you have to like change the root value according to the values in the in order array, right? So what I have done is that I just override the roots data by in orders of that particular index, and that after index I will just increment my I so that my I moves on to the next index in the in order array, so that in the next operation I will be able to uh, I will be able to change the roots data according to the in orders value, right? So this is all about the code. Let me just compile and run, and this is working. And let me just submit it. What is happening? Yeah. So problem is solved successfully, and this is all about the course. So thank you very much. I hope you like that. So thank you very much. If you like that particular solution, you may hit a like button and you may share among friends and subscribe to my channel. And I will see you in the next video. So thank you guys.